Bismillahirrahmanirrahim. Rabbi israh li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamualaikum and good day everyone. So let's proceed our lecture on the next subtopic of chapter 1 where we have vector and scalar quantities. So let's recall this one. What is vector? Vector is completely specified by a number with an appropriate unit. It means that a quantity has magnitude and also direction of it. Whereas a scalar quantity is completely specified by a single value with an appropriate unit and has no direction at all. So means that the difference between the vector and the quantity is actually the direction of it. Sometimes the direction is specified by the angle, not only to the left, to the right, up and down, or to the north, to the east or west. It also can be specified or explained by angle. For the displacement vector, so I believe you still remember this one. If let's say we are talking about motion from point A to point B, we can have two paths. Let's say we have a straight line between point A and point B, and we have a dotted line here. This is another path taken to move from point A to point B. So if we're talking about displacement, it's only concerned about the initial point and the final point. What is the difference between these 2 points is known as displacement vector. However, if we're talking about distance traveled, it's concerned about the whole path taken. So the whole length of the path taken to move from point A to point B. That is the difference between displacement and distance traveled. Let's take a look on basic vector arithmetic. Vector A is similar to vector B only if magnitude and direction of vector A is the same to the magnitude and direction of vector B. What does that mean? Both of the vector points in the same direction along parallel lines. Okay, that is the meaning. And additional information about vector can be shifted. If it is positioned here, or placed here, or shifted here, or rearranged here, it's still the same vector as long as the magnitude of it remain the same. For the arrow here, the magnitude represented by the length of it and the direction by the head of it. Okay, so as long as we maintain the magnitude and the direction, this vector can be shifted or rearranged to any other position. It is not fixed. It's still the same vector as long as the magnitude and also the direction remain the same. So now let's recall about vector addition. Let's say we have vector A plus vector B. So means that we need to figure out the resultant of it. Okay, this is the resultant of it. The R is the resultant, is equivalent to vector A plus vector B. By using tail to tip method, this is for sketching purpose. Okay, from the tail of the first vector to the tip of the second vector, connect it. This will be your resultant vector, right? And if you have more than 2, for example, A plus B plus C, so arrange it according to the process of it. A plus B plus C. Okay, so every single second and third vector, okay, must be placed at the top, the head of the vector A, the first vector, and then pointing to according to its direction, and then connected to the tail of the third vector, which is vector C, and pointing along its direction. For the resultant, okay, connect from the tail of the first vector to the tip of the third vector. So this will be our resultant. So this is for sketching purpose. Alright. Then talking about A plus B also equivalent to B plus A. This is only applicable if it is addition process. Okay. So we call this one commutative law of addition. And if you have here A plus parenthesis B plus C, close the parenthesis, it means that it's also equivalent to parenthesis A plus B parenthesis plus C, or the law of associative law of addition only applicable. Alright. Vector subtraction and scalar multiplication. Okay, if we have A plus negative A, the resultant of it will be 0. Okay, because one of it pointing to the, let's say, positive, pointing to the right, the other one pointing to the left. With the same magnitude, they're going to cancel out each other. Right? And if we take a look on this example, right, we have vector A and then we have a vector B initially. Okay, if we want to have addition of, okay, negative of B, it means that we are going to shift the B, okay, to the negative direction, make it turn 180 degree. So we have here the negative of B. Initially it is here, positive B, alright? But since the process that we're going to do, A minus B, okay, therefore we have to put the B as negative of B. So it's just like we turn the B 180 degree, right? So from the tail of the first vector to the tip of the second vector is your resultant. So here we have the resultant vector equivalent to A minus B or A plus negative of B. This is the same thing. Now take a look on this diagram. Okay. Now if we want to have C equivalent to A minus B, so what does that mean by this? Okay, to have A, okay, we have to add, okay, C to the B. Okay, that is going to produce A. In other words, actually, this equation or this process actually like this. We have first place C equivalent to A minus B. So if we rearrange the equation based on the statement given here, B, okay, and C is equivalent to A. So this is the meaning of the statement given here. Okay, vector C is the vector we must add to B to obtain A because of this one. Alright, so in terms of drawing, okay, if we have A here and we have negative B here, let me show you. In terms of drawing, okay, initially you have, let's say, this is your A, and then you have negative of B. Right? And for the C, tail to tip method, so here is your C. Similar, right, to this one? This is the meaning of it. And for scalar multiplication, if let's say we have A equivalent to 3 and let's say 3A, okay, let's say this one is in meter, let's say this is a displacement vector. If it is 3 times A, it means that 3 times 3 meter. That is the meaning of this term. Okay, now let's move to the components of a vector, also known as component method. Okay, for any vector given to us, actually, this vector is combination of two components of it. Okay, at least it has to be in two terms of components. X component and Y component. Why is it some sort of shaded or lighter color here? Means that this is just imaginary. This is the one that exists right now. This is components that make up this one, okay, the A. So if we have, this is the length of the arrow as the magnitude, the theta here as the direction, AX, okay, is actually according to the cos theta equivalent to AX over A. Why is it? If you still remember, sohkah toa. For cos theta is equivalent to adjacent side over hypotenuse. So adjacent side is AX, hypotenuse is A. So to have AX only, to know the AX, is equivalent to A cos theta. For sin theta, it's opposite side over hypotenuse. So the opposite side is the AY. Okay, so from this we can determine the AY equivalent to the hypotenuse sin theta. To have the magnitude of the A, the resultant, due to the combination of AX and AY, okay, it's equivalent to, based on Pythagoras theorem, the magnitude of A is equivalent to square root of AX square plus AY square. For the angle, okay, we are going to use tangent theta equivalent to AY over AX. To have theta only, it's uptangent of AY over AX. You may use sine or cos as well. But then it will depend on what information that we already have in our hand, okay? So we also can visualize this diagram into this diagram. It's the same. Remember, vector can be rearranged or shifted as long as we maintain the direction and the magnitude. It's the same thing. So if we want to shift AX here, also can be done. Alright? Okay, now let's take a look on the components of a vector. So if you see here, if you are considering the A is pointing into this direction within the first quadrant here, so you see the AX, the shadow, okay, lies here, is pointing to the positive X. So you see the AX will be positive value. And for the Y component of it, it is pointing to the positive Y. That is why the AY should has the positive sign as well. Now, if we are considering the vector A is lying within this quadrant, okay, the AY is positive still. However, for the AX, it will have negative sign because it's pointing towards negative X axis. Alright? And if we are considering vector A lying in this direction within this quadrant, the AX is still negative because it's pointing to the left or to the negative x-axis, and the AY also will be with the negative sign because it's pointing towards the negative y-axis. And if we put the vector A within this quadrant pointing in this direction, the AX will be positive. However, the AY will be negative sign. Right. Now, how about if the direction for the vector is in opposite direction, like this? Okay. For this one, all of it, okay, starting from origin, pointing outward, isn't it? Away from the origin. How about if the vector is pointing towards the origin? So for this case, actually, we have to consider the shadow of it, the component of it. Let's take a look for vector A. This is a AY. And here will be the AX, the shadow of it, the component of it. So according to this, for the AY, it's pointing towards the negative Y, isn't it? So this is negative Y. Here will be negative x-axis, right? So for AY, it's going to be negative sign. The AY going to have negative sign. For the AX, even though it's touching, seems like on positive x-axis, you see here, it's pointing to the left actually, towards the negative x-axis. So for the AX also has negative sign, right? Please take a look on the direction, not where your vector lies on, but then where is the direction of your components vector pointing towards which axis. Is it positive? Is it negative? Now let's take a look on vector B. For vector B, okay, we have here as your BX, and here is your BY. For the BX, even though it seems like it's lying within the quadrant where the x-axis is negative, okay, but then for the BX here, actually it's pointing towards the positive x-axis. So for the BX, it has positive sign, okay. However, for the BY, it has negative sign because it's pointing towards negative y-axis. For vector C, it only has CX, and its CX is positive, right? It has no y component, okay? It only has CX or x component, and it's positive because it's pointing towards positive x-axis. Now let's move to the vector D. For vector D, this is dx, and here is the dy. Okay, if you see the dx here pointing to the right or towards the positive x-axis, therefore for dx it has positive sign. For the dy, it's pointing towards the positive y-axis, therefore the sign for the dy also positive. Alright, so it is hopefully you are all clear about why is a component has negative sign and why some of the component has positive sign. Do not be tricked by the quadrant. Please double check the direction of your vectors. So let me show you one example on how to get the sign for the component as well as to use up the angle, whether it's cos or sine. So let's take a look on this. For vector A, okay, we have the component of it here. This is AY. This is AX. The angle given to us, okay, at this side. So I can shift it into this side, isn't it? It's the same angle, right? Okay. So now to have AY, it has negative sign. Why is it? Because it's pointing towards negative y-axis. And for AX, it has negative sign as well because it's pointing towards negative x-axis. So for AX is negative A sine sine theta. Why is it sine? Take a look. To the respect of this angle, the AX is actually opposite side. So please remember this one. Right? Now, for the AY, okay, to the respect of the angle here, the AY is actually the adjacent side. So we are going to use cos theta. Right? So AY equivalent to negative, don't forget, okay, A cos theta. So once given to you the value of each of the information, which is the theta and the A, please do the calculation properly. I'm showing to you here the concept only. Then now let's move to vector B. Vector B. So the component of vector B, we have by here and bx here. Right? So for bx, it has negative sign, which is negative b. What about the angle? This is the same angle to this. So to the respect of this angle, our bx is opposite side. Okay, so opposite side, we have the hypotenuse, the b. We want to have the opposite side, so it's going to be sine theta. So sine theta for the by is going to be b. To the respect of this angle, the by is adjacent side, so we are going to have cos theta. So b cos theta. Okay, it has positive sign because it's pointing towards positive y-axis. Right, and then let's move to vector C. How about vector C? Right, vector C is completely pointing towards y-axis. It has no x component. Therefore, for vector C, for the x component, it has 0 value. But for y component, actually it is the C itself. Right? And the direction of the C is positive because it's pointing towards positive y-axis. Even though it seems like it's lying on the negative y-axis, however, the direction is pointing towards the positive y-axis. Okay, so we have the last one, vector D. Okay, for vector D, the component of it, okay, is here and here. Oh, this one, actually dy. Right. For the x component, the dx equivalent to so take a look on this angle. The dx is adjacent side, right? And we have here d is the hypotenuse. Therefore, we're going to use cos theta. Okay, and it has negative sign, right? Because it's pointing towards negative x-axis. For the dy component, it is pointing to the positive y-axis, as shown here to the positive y-axis. Therefore, it has positive sign. So it's d sine theta. Now, we are going to determine the resultant, the product of the addition of all components. For the resultant, for the x component of the resultant, we have to do the summation of ax to the bx to the cx and dx. This will give us the rx. For the y component, we are going to do the same. We are going to total up ay plus by plus cy plus dy. This gives us the ry. This is in terms of component. We have not done yet. Next step, we are going to calculate the magnitude of the resultant by doing or by following Pythagoras. Okay, where we have here the r, the magnitude of the r, okay, is equivalent to square root of rx square plus ry square. For this example, it only has a and b. For our addition of his information just now, we have the c, the dx. Here we have cy and dy. Okay, so now for the angle, we are going to use tangent theta, ry over rx. For this case, we are going to add up. Okay, whatever it is actually ry over rx. Don't be confused. Alright, so this is your resultant, and don't forget to finally sketch your resultant lies on where. Okay, let's say this is your r with the theta. Using tangent, the angle always from x-axis. Okay, whether positive x-axis or negative x-axis. Okay. This is example 1.13. Okay, take a look on this. A hiker begins a trip by first walking 25 kilometers 45 degrees south of east from her base camp. Right, on the second day, she walks 40 kilometers in a direction 60 degrees north of east, at which point she discovers a forest ranger's tower. Determine the components of the hiker's displacement in the first and second days. Determine the components of the hiker's total displacement for the trip. And C, find the magnitude and direction of the displacement from the base camp. Okay, so how to visualize the information given to us? The first vector, okay, let's say vector A, okay, 25 kilometer 45 degrees south of east. So it means that 45 degree here is measured from east towards south. So the east will be our reference. Move toward the south about 45 degree. So if we're talking about northeast, south and west, okay, so here will be our east, isn't it? Positive x is our east, here is our north, here will be our south, and toward this will be our west. Okay, so now we have vector A, the magnitude of it 25 kilometers, the angle from x-axis, okay, from x-axis 45 degree. How to put it? From the east toward the south. That is how. Okay, now for the vector B, second vector, okay, 60 degree north of east. Okay, so take a look at this. Okay, north of east. So means that from east, okay, remember, positive x-axis become our east direction. So from east towards the north with 60 degree of angle. Okay, so here will be our vector B. Okay, so the resultant based on tail to tip, we can predict that it lies here. Okay, our resultant is right. So we're going to take a look and calculate it one by one. Okay, and once we have the resultant, if we are referring to the resultant by itself, the component of it will be in this method, right? So let's take a look on the solution given. So first thing first, you are going to determine the AX, AY, BX, BY. Take a look on this. For AY, it has negative sign. Okay, so whether you want to put it like this or you do it in terms of table, just like I showed you just now, okay, it's up to you. But I prefer table method because it's avoid from any mistake that we left any vector. Okay, for part B, now you're going to determine the resultant by adding up vector A to vector B. Okay, so when we do the addition, it means that we have to add up the component of it. Alright, so this is your Rx, this is your Ry. To know the magnitude and also the direction of the resultant vector, we are going to use Pythagoras, okay, where the magnitude of the resultant, the R, equivalent to Rx square plus Ry square, square root of them. That is the magnitude. To determine the angle of your resultant, we are going to use tangent theta equivalent to Ry over Rx. And finally, the angle is 24.1 degree. Alright, for the exercise 1.13, okay, I'm going to give you a hint or slightly a bit guide information. A cruise ship leaving port travel 50 kilometers 45 degree north of west. So if we visualize the first vector here, okay, from the west towards the north, okay, this is an angle of 45 degree, and here lies our vector A, the first vector, with magnitude of 50 kilometers. And then 70 kilometers at a heading 30 degree north of east. So north of east. So from east, remember, positive x is our east. So from east towards the north with angle of 30 degree. So this will be where our second vector or vector B lies on, with the magnitude of 70 kilometers. Okay, so this is the visualization of our exercise 1.13. Okay, and then the question asking for the components of the ship displacement vector and the displacement vector's magnitude and direction. The answer already given here. You are going to do exactly like mine, okay, and solve for every single vector here. Calculate the component of the R, magnitude of the R, and finally the direction of the R. Okay, based on tail to tip method, by right, your resultant should be lying somewhere here. This is your R, resultant vector. Okay, take this one as your homework. Okay, solve it. Make sure you'll be able to get the answer as given here. That's it for chapter 1. I would like to highlight on Surah Al-Baqarah, chapter 2, verse 33. Qala ya Adamu anbi'hum bi asma'ihim. Falamma anba'ahum bi asma'ihim qala alam aqul lakum inni a'lamu ghaibas samawati wal ard wa a'lamu ma tubduna wa ma kuntum taktumun. Then he said to Adam, convey to them their names. And when he had told them, God said, I did not tell you that I know the unknown of the heavens and the earth, and I know what you disclose and know what you hide. I can conclude that all the information, all the knowledge coming from Allah, only disclosed by Allah Ta'ala to us. So we all have to stay humble and always ask Him for understanding, for the knowledge, for the skill, okay, that we should be gaining by learning. That's all from me. Thank you very much for watching. Have a pleasant day. Assalamualaikum warahmatullahi wabarakatuh.